This is the presentation for microcontrollers and the alternatives for the development of IoT devices. The members of this research are Orlando Saldaña, Jan Rivera, William Negron, Rebecca Rivera, Jose Rodriguez, Hedin Garcia, and Giomar Santiago. As performance and access to the internet has increased, Internet of Things devices have also followed this trend. It is projected that by the year 2025, there will be almost 25 billion IoT devices. The range of functionalities that these devices provide can vary greatly, anywhere from using AI to detect traffic patterns to detecting faults in an automated process through hundreds of sensors. These different applications require hardware that is power efficient and has the computational power to achieve their goals. This is an analysis of the different hardware solutions available.
The Internet of Things is one of the most important technologies of this century, and one that promises to keep increasing. It refers to a system of objects that are internet connected that collect and process data on a wireless network. In order to collect the data, the object uses embedded systems and sensors to transmit it regularly. Some IoT applications are really common, and we see them over on our daily life. Some of the most prominent ones are smart cities, smart homes, smart agriculture, and smart grid and energy saving.
In this research, the microcontroller NVIDIA Jetson Nano Developer Kit was considered for the purpose to employ in IoT applications. Part of its advantages is that it is a low-cost, powerful, modern AI computer that delivers 472 gigaflops of compute performance for running modern AI workloads. In the aspect of IoT, the Jetson Nano helps move the amount of AI and machine learning work to the edge. Local inference can be done on the microcontroller, then send its data to the cloud to improve model training. The Jetson Nano contains a software stack which has libraries for deep learning and computer vision. As another advantage, the microcontroller can run a variety of advanced machine learning frameworks including TensorFlow, PyTorch, and others.
The Just Nano doesn't really have a big problem that will make you turn your back against it and not use it. But some of the problem it does have is that it requires a micro SD card of at least 32 gigabytes to use as a boot device and for main storage, since it doesn't have an internal one. Also, if you're running heavy workload, the thermal limit may be reached and an external fan will be needed. And if you want to use Wi-Fi connection, an external adapter is needed since it doesn't have built Wi-Fi. So having to buy all of this stuff also ends up increasing the price point of the Jetson Nano.
Now I will talk about some of the pros of the Raspberry Pi 4. In its GPIO, it had some multifunction pins, which can be used for different protocols as SPI, I2C, UART, and PCM. Also, it has a full operating system, which in this case is Raspbian OS, which is based on the operating system Linux, so it makes it a single board computer. You can program in more than one language, which can be Python, C, or Java. It has a lot of open source library which can be very useful at the moment of making a project. Also, it has a lot of accessories available for the GPIOs as for the USB, which can be cameras, cases, sensors, etc. And for the IoT part, it has a Wi-Fi, Ethernet, and Bluetooth connectivity, which makes it really useful at the moment of IoT projects, and has a ARM processor, which is powerful for this kind of task.
One of the disadvantages of using a Raspberry Pi is that since it has an operating system that the processor has to run, this can diminish the speed at which the system can execute other tasks. Another disadvantage would be that it does not have the ability to natively accept analog input, which means you would need to use an analog to digital converter. Along with this, it is also sensitive to power. Unlike other microcontrollers, it cannot accept 5 volts on its GPIO pins, only 3.3 volts. Lastly, it does not have a dedicated graphics processor, meaning all the graphic tasks are handled by the main processor.
FPGAs are another alternative when designing IoT devices. They are very flexible in their range of functionality because the hardware is user programmable. They can be highly power efficient and are usually used as hardware accelerators due to their parallelization capabilities. They also allow for better control over the I/O of the system. Some disadvantages are that the design is more complex due to the need for both hardware and software design, and FPGAs tend to have a higher cost per unit than other alternatives.
Some of the advantages that you will see in an AVR microcontroller is that it has a manageable price for great quality, supplies hardware architecture providing a wider memory for the data bus. It uses RISC, utilizing small, highly optimized set of instructions, has the ability to simulate projects before implementation, validating the whole system behavior as early as possible, provides variation of peripherals, which increases the opportunities to interface with the world outside of the microcontroller, helping perform certain functions. And you don't have to go through the process of setting up external memory because it already has an onboard memory.
Hi, my name is Jose Rodriguez. Thank you, Rebecca, for that. Now we are going to know about the disadvantage about the AVR microcontroller. The first one, the AVR microcontroller has 118 instructions which are more complicated than the former. That means you need a high level of knowledge in C++ to program that microcontroller. The second one is compared to other microcontroller, the AVR tends to draw more current than others like the PAC. The third one is it only have one analog comparator. And the last one is the AVR microcontroller only works an external oscillator speed of only 20 megahertz.
For our future work, we would like to explore the capabilities of other IoT alternatives, apply the skills gained to real-world problems, deepen our understanding of digital design for FPGAs, and design an IoT device for a more specific application.
Each device has a particular task that it performs better than the rest. For IoT application, those devices with integrated wireless communication tend to be a better choice, but it should not be the only factor taken into consideration in the decision process. Thank you all for attending our presentation.